Learning objectives. In this chapter, the user would be learning about C# basics and the following in detail. Data types, identifiers, variables and constants, C# statements, object-oriented concept, object and classes, arrays and strings, system collections, delegates and events, indexes, attributes, versioning. C# basics. Introduction. C# is designed for Common Language Infrastructure (CLI), which consists of the executable code and runtime environment that allows use of various high-level languages to be used on different computer platforms and architectures. The following reasons make C# a widely used professional language. It is a modern general-purpose programming language which is both object-oriented and component-oriented. C# is easy to learn and it is a structured language for effective programs. It can be compiled on a variety of computer platforms, part of .NET framework. C# constructs closely follow traditional high-level languages, C and C++, and being an object-oriented programming language, it has strong resemblance with Java. Moreover, it has numerous strong programming features that make it endearing to a multitude of programmers worldwide. Following is a list of a few important features. Boolean conditions, automatic garbage collection, standard library, assembly versioning, properties and events, delegates and events management, easy-to-use generics, indexers, conditional compilation, simple multithreading, LINQ and Lambda expressions, integration with Windows. C# program structure. Before we study basic building blocks of the C# programming language, let us look at the bare minimum C# program structure, which consists of namespace declaration, class, class methods, class attributes, main method, statements and expression and comments. It's worth noting the following points. C# is case-sensitive, where all the statements and expressions must end with a semicolon. Every C# program execution starts at the main method. It is not like Java, for file name could be different from the class name. Compile and execute a C# program. To compile and execute a C# program, certain steps need to be followed starting from Visual Studio. From the menu bar, choose File, New and Project. A window will appear. Then choose Visual C# from Templates and then choose Windows. Choose Console Application. Specify a name for your project and then choose the OK button. The new project appears in Solution Explorer. Write code in the code editor. Click the Run button or the F5 key to run the project. A command prompt window appears that contains the line, Hello World. C# basic syntax. C# is an object-oriented programming language. In object-oriented programming methodology, a program consists of various objects that interact with each other by means of actions. The actions that an object may take are called methods. Objects of the same kind are said to have the same type or more often are said to be in the same class. The first statement in any C# program is using system, and the class keyword is used for declaring a class. Comments are used for explaining code. Variables and functions are data members and tasks of a specific code. Data types. In C# programming, the variables are categorized into the three following types, namely value types, reference types, and pointer types. Value types. In C# programming language, value type variables can be assigned a value directly. They are derived from the class system.valueType. The value types directly contain data. Some examples are int, char, float, which stores numbers, alphabets, floating point numbers, respectively. When you declare an int type, the system allocates memory to store the value. Reference types. The reference types do not contain the actual data stored in a variable, but they contain a reference to the variables. In other words, they refer to a memory location. Using more than one variable, the reference types can refer to a memory location. If the data in the memory location is changed by one of the variables, the other variable automatically reflects this change in value. Example of built-in reference types are object, dynamic, and string. The object type is the ultimate base class for all data types in C# Common Type System, CTS. Dynamic type can store any type of value in the dynamic data type variable. The string type allows you to assign any string values to a variable. Pointer types. Pointer type variables store the memory address of another type. Pointers in C# have the same capabilities as in C or C++. Its syntax for declaring a pointer type is as shown. Other examples are also shown. Identifiers. An identifier is a name used to identify a class, variable, function, or any other user-defined item. The basic rules for naming classes in C# are as follows. A name must begin with a letter that could be followed by a sequence of letters, digits 0 to 9, or underscore. The first character in an identifier cannot be a digit. It must not contain any embedded space or symbol like those shown on screen. However, an underscore can be used. It should not be a C# keyword. Variables. In C#, a variable is nothing but a name given to a storage area that our programs can manipulate. Each variable in C# has a specific type which determines the size and layout of the variable's memory, the range of values that can be stored within that memory, and the set of operations that can be applied to the variable. The basic value types provided in C# can be categorized as shown. Variable definition in C#. Syntax for variable definition in C# is as shown. Here, data types must be a valid C# data type including char, int, float, double, or any user-defined data type, and variable list may consist of one or more identifier names separated by commas. Some valid variable definitions are shown in the figure. Variable initialization in C#. The general form of initialization is as shown. Variables can be initialized, assigned an initial value in their declaration. The initializer consists of an equal sign followed by a constant expression. It is a good programming practice to initialize variables properly, otherwise sometimes program would produce unexpected results. Some examples are shown in the figure. Accepting values from the user. The console class in the system namespace provides a function readline for accepting input from the user and storing it into a variable. An example is shown on screen. The function convert to int32 converts the data entered by the user to int data type because the console.readline accepts the data in string format. L values and R values in C#. There are two kinds of expressions in C#: L value, R value. L value, an expression that is an L value, may appear as either the left-hand or right-hand side of an assignment. R value, an expression that is an R value, may appear on the right but not left-hand side of an assignment. Variables are L values and so may appear on the left-hand side of an assignment. Numeric literals are R values and so may not be assigned and cannot appear on the left-hand side. A valid statement is shown on the screen. Constants. In C#, the constants refer to fixed values that the program may not alter during its execution. These fixed values are also called literals. Constants can be of any of the basic data types like an integer constant, a floating constant, a character constant, or a string literal. There are also enumeration constants as well. The constants are treated just like the regular variables, except that the values cannot be modified after their definition. Integer literals. Here an integer literal can be a decimal, octal, or hexadecimal constant. A prefix specifies the base or radix. 0x or 0X for hexadecimal, 0 for octal, and no prefix is required for decimal numbers. An integer literal can also have a suffix that is a combination of U and L, for unsigned and long respectively. The suffix can be uppercase or lowercase and can be in any order. Here are some examples of integer literals. Floating point literals. A floating point literal has an integer part, a decimal point, a fractional part, and an exponent part. You can represent floating point literals either in decimal form or exponential form. Here are some examples of floating point literals. While representing using decimal form, you must include the decimal point, the exponent, or both, and while representing using exponential form, you must include the integer part, the fractional part, or both. The signed exponent is introduced by e, or e, small or big. Character constants. Character literals are enclosed in single quotes like shown and can be stored in a simple variable of char type. A character literal can also be a plain character, an escape sequence, or a universal character as shown. A list of some escape sequence codes. There are certain characters in C# which, when preceded by a backslash, will have special meaning and they are used to represent, say, a new line or tab. String literals. String literals or constants are enclosed in double quotes or with the symbol @. A string contains characters that are similar to character literals, plain characters, escape sequences, and universal characters. A C# program that concatenates string literals. You can break a long line into multiple lines using string literals and separating the parts using white spaces. Here are some examples of string literals. All the three forms are identical strings. Defining constants. Constants are defined using the const keyword. Syntax for defining a constant is as shown. The following program demonstrates defining and using a constant in your program. When the code is compiled and executed, it produces the following result. Statements. Statements in C# are single entities that cause a change in the program's current state. A statement ends with a semicolon, which will generate a compiler error if forgotten. Statements may span multiple lines, which could help make your code more readable. Decision-making structures require that the programmer specify one or more conditions to be evaluated or tested by the program, along with a statement or statements to be executed if the condition is determined to be true, and optionally, other statements to be executed if the condition is determined to be false. If statements. In C#, if statements allow evaluation of an expression, and depending on the truth of the evaluation, their capability to branch to a specified sequence of logic. C# provides three forms or if statements. Simple if then else, and if else, if else. Syntax. The syntax of an if statement in C# is as shown. If-else statement. The simple if statement guarantees you can only perform certain actions on a true condition. It's either done or it's not. To handle both the true and false conditions, use the if-then-else statement. The syntax of an if-else statement in C# is as shown. The if, else if, else statement. An if statement can be followed by an optional else if, else statement, which is very useful to test various conditions using single if, else if statement. Use the syntax of an if, else if, else statement in C# as shown. When using if, else if, else statements, there are a few points to keep in mind. An if can have 0 or 1 elses, and it must come after any else ifs. An if can have 0 to many else ifs, and they must come before the else. Once an else if succeeds, none of the remaining else ifs or elses will be tested. Nested if statements. In C#, it is always legal to nest if-else statements, which means you can use one if or else if statement inside another if or else if statements. You can nest else if, else in the similar way as you've nested if statement. The syntax for a nested if statement is as shown. Switch statement. When there are many conditions to evaluate, the if-else statement can become complex and verbose. Sometimes a much cleaner solution is a switch statement. The switch statement allows testing any integral value or string against multiple values. The syntax for a switch statement in C# is as shown. A switch statement allows a variable to be tested for equality against a list of values. Each value is called a case, and the variable being switched on is checked for each switch case. The following rules apply to a switch statement. The expression used in a switch statement must have an integral or enumerated type, or be of a class type in which the class has a single conversion function to an integral or enumerated type. You can have any number of case statements within a switch. Each case is followed by the value to be compared to and a colon. The constant expression for a case must be the same data type as the variable in the switch, and it must be a constant or a literal. When the variable being switched on is equal to a case, the statements following that case will execute until break statement is reached. When a break statement is reached, the switch terminates and the flow of control jumps to the next line following the switch statement. Not every case needs to contain a break. If no break appears, the flow of control will fall through to subsequent cases until a break is reached. A switch statement can have an optional default case which must appear at the end of the switch. The default case can be used for performing a task when none of the cases is true. No break is needed in the default case. Nested switch statement. It is possible to have a switch as part of the statement sequence of an outdoor switch. The syntax for a nested switch statement is as shown. Even if the case constants of the inner and outer switch contain common values, no conflicts will arise. C# loops. In C#, there are 4 types of loops: while loop, do loop, for loop, for each loop. Each has its own benefits for certain tasks. While loop. There may be a situation when you need to execute a block of code several numbers of times. The syntax of while loop in C# is as shown. In general, statements are executed sequentially. Here, statements may be a single statement or a block of statements. The condition may be any expression, and true is any non-zero value. The loop iterates while the condition is true. When the condition becomes false, program control passes to the line immediately following the loop. For loop. A for loop is a repetition control structure that allows you to efficiently write a loop that needs to execute a specific number of times. The syntax of a for loop in C# is as shown. Initialize. This step allows you to declare and initialize any loop control variables. Condition. The condition is evaluated. If it is true, the body of the loop is executed. If it is false, the body of the loop does not execute, and flow of control jumps to the next statement just after the for loop. Increment or decrement. The condition is now evaluated again. If it is true, the loop executes and the process repeats itself. Increment or decrement step. After the condition becomes false, the for loop terminates. Do while loop. A do-while loop is similar to a while loop, except that a do-while loop is guaranteed to execute at least one time. If the condition is true, the flow of control jumps back to do, and the statements in the loop execute again. This process repeats until the given condition becomes false. The syntax of a do-while loop in C# is examples of C# program that uses do-while loop. Notice that the conditional expression appears at the end of the loop, so the statements in the loop execute once before the condition is tested. Nested loops. C# allows using one loop inside another loop. The syntax for a nested loop for loop statement in C# is as shown. The following section shows a few examples to illustrate the concept. A final note on loop nesting is that you can put any type of loop inside of any other type of loop. For example, a for loop can be inside a while loop or vice versa. Break statement. The break statement in C# has the following 2 usages. When the break statement is encountered inside a loop, the loop is immediately terminated and the program control resumes at the next statement following the loop. It can be used to terminate a case in the switch statement. If you're using nested loops, one loop inside another loop, the break statement will stop the execution of the innermost loop and start executing the next line of code after the block. The syntax for a break statement in C# is as shown. Continue statement. The continue statement in C# works somewhat like the break statement. The syntax for a continue statement in C# is as shown. Examples of C# program for a continue statement. Instead of forcing termination, however, continue forces the next iteration of the loop to take place, skipping any code in between. For the for loop, continue statement causes the conditional test and increment portions of the loop to execute. For the while and do while loops, continue statement causes the program control to pass to the conditional tests. The infinite loop. A loop becomes infinite loop if a condition never becomes false. The for loop is traditionally used for this purpose. Since none of the three expressions that form the for loop are required, you can make an endless loop by leaving the conditional expression empty. Example of C# program for infinite loop. When the conditional expression is absent, it is assumed to be true. You may have an initialization and increment expression, but programmers more commonly use the for construct to signify an infinite loop as shown. Designing objects. From a software perspective, those items selected are referred to as objects, such as custom class or struct. You would further refine those objects to hold members, which define attributes and behavior. Example of a C# program that uses object. This session shows you how to create objects and define their members. The attributes and behavior would map to C# language elements. An attribute could be a field or property, and a behavior could be a method or event. This is the world of objects, and by building objects that represent real-world entities, you can build more meaningful systems. Object members. In .NET, objects are self-contained with a single purpose in mind. All included members should be compatible. Here's a simple class skeleton. In this example, the class keyword tells that this is a class, a custom reference type. The name website is the name of the class, and the class members are contained within the braces. This could have been a struct instead, but that would have made it a value type. Instance and static members. Each member of an object can be classified in one of two ways: instance member or static member. When a copy of an object is created, it is considered instantiated. At that point, the object exists as a sole entity with its own set of attributes and behavior. If a second instance of that object were created, it would normally have a separate set of data from that of the first object instance. In C#, object members belong to the instance unless modified as static. An example of instance objects is a customer class, where every customer has different information. Fields. Fields comprise the primary data portion of a class. Examples of C# program for fields. They are the state of an object. They are members of a class as opposed to local variables, which are defined inside of methods and properties. Constants are efficient. Their values are known at compile time. This enables certain optimizations unavailable to other types of fields. By definition, constants are also static. Read-only fields are similar to constant fields in that they can't be modified after initialization. The biggest difference between the two is when they are initialized. Constants are initialized during compilation, and read-only files are initialized during runtime. Methods. Methods are some of the most common object members you will work with. A C# method is similar to functions, procedures, subroutines, and so on in other programming languages. The preceding method, designing object-oriented programs. The following sections drill down on these subjects, which are three of the principles of object-oriented programming: inheritance, encapsulation, and polymorphism. Abstraction, a fourth pillar of object-oriented programming. Building objects from a high-level perspective so that you don't have to be concerned about the lower-level details. In this session, you learn about building objects and managing the public members to create new abstractions. Inheritance. Inheritance is an object-oriented principle relating to how one class or a derived class can share the characteristics and behavior from another class, a base class. This can be thought of as an is-a relationship because the derived class can be identified by both its class type and its base class type. The benefits gained by this are the ability to reuse the base class members and to add additional members to the derived class. The derived class then becomes a specialization of the base class, parent. This specialization can continue for as many levels as necessary, each new level derived from the base class above it. Base classes. Normal base classes may be instantiated themselves or inherited. Derived classes inherit each base class member marked with protected or greater access. The derived class is specialized to provide more functionality in addition to what its base class provides. Here's an example for base class. A derived class declares that it inherits from a base class by adding a colon and the base class name after the derived class name. Calling base class members. Derived classes can access the members of the base class if those members have protected or greater access. A later section on the object-oriented principle of encapsulation goes into greater depth on access modifiers. A base class member with a protected or public modifier can be accessed by derived classes. Just use the member name as if that member were a part of the derived class itself. Here's an example. In this example, the GenerateReport method of the customer class calls a full address method in its base class, contact. All classes have full access to their own members without qualification. Qualification refers to using a class name with the dot operator to access a class member. MyObject.sum method, for instance. Hiding base class members. Derived class members have the same name as a corresponding base class member, meaning that they are defining the base class method in the derived class. When using an instance of the derived class, you invoke the derived class's specialized behavior and not the behavior of that method in the base class. In this case, the derived member is said to be hiding the base class member. When hiding occurs, the derived member is masking the functionality of the base class member. Users of the derived class won't be able to see the hidden member. They'll see only the derived class member. Versioning. Versioning, in the context of inheritance, is a C# mechanism that allows modification of classes, creating new versions without accidentally changing the meaning of the code. Hiding a base class member with the methods previously described generates a warning message from the compiler. This is because of the C# versioning policy. It's designed to eliminate a class of problems associated with modifications to base classes. Here's a scenario. A developer creates a class that inherits from a third-party library. We assume that the contact class represents the third-party library. Encapsulation. Encapsulation is the object-oriented principle associated with hiding the internals of an object from the outside world. C# has several mechanisms for supporting encapsulation, including properties, indexes, methods, and access modifiers. In this section, you will see how to use the features of C# to achieve encapsulation. There are several reasons to take advantage of C#'s built-in mechanisms. Good encapsulation reduces coupling. By clearly defining a public interface, what other code sees, and hiding everything else, users can write code with less dependency on that object. Internal implementation of an object can freely change. This reduces the possibility of breaking someone else's code. An object has a much cleaner interface. Users see only those members that are exposed, which reduces the amount of understanding they need to use the object. It simplifies reuse. Data hiding. One of the most useful forms of encapsulation is data hiding. Most of the time, users shouldn't have access to the internal data of an object. Data represents the state of an object, and an object normally has full control of its own state to ensure consistency. Anytime access to data is open, the potential of someone else wreaking havoc with the operation of that object increases. Sometimes it's logical and necessary to expose object data, especially if it's necessary to expose constants, enumerations, and read-only files. Perhaps the design goal is to increase the efficiency of data access for a field that's accessed frequently. Modifiers supporting encapsulation. C# manages object encapsulation with appropriate use of C# access modifiers, which specify which code can access class members. They also control the method of access. You apply different sets of access modifiers depending on whether you're working with objects or object members. You see access modifiers applicable to object members first, followed by which modifiers apply to types. Public access specifier. Public access specifier allows a class to expose its member variables and member functions to other functions and objects. Any public member can be accessed from outside the class. The following example illustrates this. In the preceding example, the member variables length and width are declared public, so they can be accessed from the function main using an instance of the rectangle class named R. The member function display and the get area can also access these variables directly without using any instance of the class. The member function's display is also declared public, so it can also be accessed from main using an instance of the rectangle class named R. Private access specifier. Private access specifier allows a class to hide its member variables and member functions from other functions and objects. Only functions of the same class can access its private members. Even an instance of a class cannot access its private members. The following example illustrates this. In the preceding example, the member variables length and width are declared private, so they cannot be accessed from the function main. The member functions accept details and display can access these variables. Since the member functions accept details and display are declared public, they can be accessed from main using an instance of the rectangle class named R. Protected access specifier. Protected access is a little less restrictive than private access, but more restrictive than public. The only way to use a protected member is via members of the same class or through inheritance. A derived class has full access to protected base class members. Another feature of this particular example is that the protected member is a property and not a field. This gives Contact the capability to encapsulate its implementation, yet share access at a level necessary for the job. Had the age information been exposed as a protected field, the coupling between derived classes such as customer would constrain Contact and make maintenance more difficult. Internal access specifier. Internal access restricts visibility to only code within the same assembly. I briefly described an assembly as a unit of deployment, execution, identity, and security. An assembly is also a unit of containment where you may restrict access via internal modifiers. Here's an example of internal members. To use internal access effectively, you create a class library project in VS 2008. Any code inside of that class library can access your internal members, but other code that references the assembly can't. Protected internal access specifier. The protected internal access specifier allows a class to hide its member variables, member functions from other class objects and functions. Here's an example of protected internal access specifier. Accept a child class within the same application. This is also used while implementing inheritance. Polymorphism. The word polymorphism means having many forms. In object-oriented programming paradigm, polymorphism is often expressed as one interface, multiple functions. Polymorphism can be static or dynamic. In static polymorphism, the response to a function is determined at the compile time. In dynamic polymorphism, it is decided at runtime. Static polymorphism. In C#, the mechanism of linking a function with an object during compile time is called early binding. It is also called static binding. C# provides two techniques to implement static polymorphism. These are function overloading, operator overloading. Function overloading. You can have multiple definitions for the same function name in the same scope. The definition of a function must differ from each other by the types and/or the number of arguments in the argument list. You cannot overload function declarations that differ only by return type. Following is an example where this function display is being used to print different data types. The definition of the function must differ from each other by the types and/or the number of arguments in the argument list. You cannot overload function declarations that differ only by return type. Dynamic polymorphism. C# allows you to create abstract classes that are used to provide partial class implementation of an interface. Implementation is completed when a derived class inherits from it. Abstract classes contains abstract methods which are implemented by the derived class. The derived classes have more specialized functionality. Please note the following rules about the abstract classes. You cannot create an instance of an abstract class. You cannot declare an abstract method outside an abstract class. When a class is declared sealed, it cannot be inherited. Abstract classes cannot be declared sealed. The following program demonstrates an abstract class. When the code is compiled and executed, it produces the following result. Operator overloading. You can redefine or overload most of the built-in operators available in C#. Thus, a programmer can use operators with user-defined types as well. Overloaded operators are functions with special names for the keyword operator, followed by the symbol for the operator being defined. Like any other function, an overloaded operator has a return type and a parameter list. The above functions implements the addition operator plus for a user-defined class box. It adds the attributes of two box objects and returns the resultant box object. For example, look at the following function. When the code is compiled and executed, it produces the following result. Object and classes. Class. Class definition. A class definition starts with the keyword class followed by the class name, and the class body ended by the end class statement. The following is the general form of a class definition, where attribute list is a list of attributes that apply to the class. Optional. Access modifier defines the access levels of the class. It has values as public, protected, friend, protected friend, and private. Optional. Shadows indicate that the variable redeclares and hides an identically named element or set of overloaded elements in a base class. Optional. Must inherit specifies that the class can be used only as a base class and that you cannot create an object directly from it. That is an abstract class. Optional. Object. It is a real-time entity. An object can be considered a thing that can perform a set of related activities. The set of activities that the object performs defines the object's behavior. In pure OOP terms, an object is an instance of a class. Example program for an object. Member functions and encapsulation. A member function of a class is a function that has its definition, prototype within the class definition like any other variable. It operates on any object of the class of which it is a member and has access to all the members of a class for that object. Member variables are attributes of an object from a design perspective, and they are kept private to implement encapsulation. These variables can only be accessed using the public member functions. In this example, we encapsulate some data such as height, width, thickness, and method getVolume. Other methods or objects can interact with this object through methods that have public access modifier. Array. An array stores a fixed size sequential collection of elements of the same type. An array is used to store a collection of data. Instead of declaring individual variables such as number 0, number 1, and so on until number 99, declare one array variable such as numbers and use numbers 0, 1, and so on to represent individual variables. All arrays consist of contiguous memory locations. The lowest address corresponds to the first element and the highest address to the last element. Declaring array. To declare an array in C#, you can use the following syntax, where data type is used to specify the type of elements to be stored in the array. Square bracket specifies the rank of the array. The rank specifies the size of the array. Array name specifies the name of the array. For example, initializing an array. Declaring an array does not initialize the array in the memory. When the array variable is initialized, you can assign values to the array. Array is a reference type, so you need to use a new keyword to create an instance of the array. For example, assigning values to an array. You can assign values to individual array elements by using the index number, like you can assign values to the array at the time of declaration, like You can also create and initialize an array like. When you create an array, C# compiler implicitly initializes each array element to a default value depending on the array type. For example, for an int array, all elements will be initialized to 0. Accessing array elements. An element is accessed by indexing the array name. This is done by placing the index of an element within square brackets after the name of the array. Multidimensional arrays. C# allows multidimensional arrays. Multidimensional arrays are also called rectangular arrays. You can declare a two-dimensional array of strings as a three-dimensional array of int variables. The simplest form of the multidimensional array is a two-dimensional array. A two-dimensional array is in a sense a list of one-dimensional arrays. A two-dimensional array can be thought of as a table which will have x number of rows and y number of columns. Following is a two-dimensional array which contains 3 rows and 4 columns. Jagged arrays. A jagged array is an array of arrays. You can declare a jagged array scores of int values as. Passing arrays to functions. You can pass an array as a function argument in C#. The following example demonstrates this. When the code is compiled and executed, it produces the following result. Array class. The array class is the base class for all the arrays in C#. It is defined in the system namespace. The array class provides various properties and methods to work with arrays. IsFixedSize gets a value indicating whether the array has a fixed size. IsReadOnly gets a value indicating whether the array is read-only. Length gets a 32-bit integer that represents the total number of elements in all the dimensions of the array. LongLength gets a 64-bit integer that represents the total number of elements in all the dimensions of the array. Rank gets a rank, number of dimensions of the array. Strings. In C#, you can use strings as array of characters. However, a more common practice is to use a string keyword to declare a string variable. The string keyword is an alias for system.string class. Creating a string object. You can create string object using one of the following methods. By assigning a string literal to a string variable, by using a string class constructor, by using the string concatenation operator, plus by retrieving a property or calling a method that returns a string, by calling a formatting method to convert a value or object to its string representation. When the code is compiled and executed, it produces the following result. The string class has the following two properties. Chars gets a char object at a specified position in the current string object. Length gets the number of characters in the current string object. The following example demonstrates some of the methods. Comparing strings. When the code is compiled and executed, it produces the following result. String contains string. When the code is compiled and executed, it produces the following result. Getting a substring. When the code is compiled and executed, it produces the following result. Joining strings. When the code is compiled and executed, it produces. System collections. Collection classes serve various purposes, such as allocating memory dynamically to elements and accessing a list of items on the basis of an index, etc. These classes create collections of objects of the object class, which is the base class for all data types in C#. Collection classes are specialized classes for data storage and retrieval. These classes provide support for stacks, queues, lists, and hash tables. Most collection classes implement the same interfaces. ArrayList. It represents an ordered collection of an object that can be indexed individually. It is basically an alternative to an array. However, unlike an array, you can add or remove items from a list at a specified position using an index, and the array resizes itself automatically. It also allows a dynamic memory allocation, adding, searching, and sorting items in the list. Methods and properties of the ArrayList class are shown. The following table lists some of the commonly used properties of the ArrayList class. The following example demonstrates the concept. When the code is compiled and executed, it produces the following result. Hash table. The hash table class represents a collection of key and value pairs based on the hash code of the key that are organized. It uses the key to access the elements in the collection. The following table lists some of the commonly used properties of the hash table class. The following example illustrates this. A hash table is used when you need to access elements by using key, and you can identify a useful key value. Each item in the hash table has a key-value pair. The key is used to access the items in the collection. Sorted list. The sorted list class represents a collection of key and value pairs that are sorted by the keys and are accessible by key and by index. A sorted list is a combination of an array and an hash table. It contains a list of items that can be accessed using a key or an index. If you access items using an index, it is an array list, and if you access items using a key, it is a hash table. The collection of items is always sorted by the key value. The following example demonstrates the concept. When the code is compiled and executed, it produces a stack. It represents a last-in, first-out collection of objects. It is used when you need a last-in, first-out access of items. When you add an item in the list, it is called pushing the item. When you remove it, it is called popping the item. The following table lists the commonly used properties of a stack class. The following example demonstrates the use of stack. When the code is compiled and executed, it produces the following result. Queue. It represents a first-in, first-out collection of objects. It is used when you need a first-in, first-out access of items. When you add an item in the list, it is called enqueue. When you remove an item, it is called dequeue. The following table lists the commonly used properties of the queue class. The following example demonstrates the use of stack. When the code is compiled and executed, it produces the following result. Bit array. The bit array class manages a compact array of bit values, where true indicates that the bit is on 1 and the false indicates that the bit is off 0. It is used when you need to store the bits but do not know the number of bits in advance. You can access the items from a bit array collection by using an integer index, which starts from 0. The following example demonstrates the use of bit array class. When the code is compiled and executed, it produces the following result. Delegates. C# delegates are similar to pointers to functions in C or C++. A delegate is a reference type variable that holds a reference to a method. The reference can be changed at runtime. Delegates are specially used for implementing events and the callback methods. All delegates are implicitly derived from the system.delegate class. Declaring delegates, instantiating delegates, multicasting of a delegate, use of a delegate. Declaring delegates. Syntax for delegate declaration is: example, delegate declaration determines the methods that can be referenced by the delegate. A delegate can refer to a method which has the same signature as that of the delegate. Instantiating delegates. Once a delegate type has been declared, a delegate object must be created with a new keyword and be associated with a particular method. When creating a delegate, the argument passed to the new expression is written like a method call, but without the arguments to the method. For example, when the code is compiled and executed, it produces the following result. Multicasting of a delegate. The following program demonstrates multicasting of a delegate. Delegate objects can be composed using the plus operator. A composed delegate calls two delegates it was composed from. Only delegates of the same type can be composed. The minus operator can be used to remove a component delegate from a composed delegate. Using this useful property of delegates, you can create an invocation list of methods that will be called when a delegate is invoked. This is called multicasting of a delegate. When the code is compiled and executed, it produces the following result. Use of delegate. The following example demonstrates the use of delegate. The delegate print string can be used to reference methods that take a string as input and return nothing. When the code is compiled and executed, it produces the following result. Events. An event is a delegate with special features in the areas of type membership, limitations on invocation, and assignment. By having events as first-class type members, along with fields, methods, and properties, C# becomes a more component-oriented language. This means that other objects can listen for changes in your object and receive notifications via event invocations. Using delegates with events. The events are declared and raised in a class and associated with the event handlers using delegates within the same class or some other class. The class containing the event is used to publish the event. This is called the publisher class. Some other class that accepts this event is called the subscriber class. Events use the publisher-subscriber model. A publisher is an object that contains a definition of the event and the delegate. The event-delegate association is also defined in this object. A publisher class object invokes the event and it is notified to other objects. A subscriber is an object that accepts the event and provides an event handler. The delegate in the publisher class invokes a method event handler of the subscriber class. When the code is compiled and executed, it produces the following result. Indexes. Declaration of behavior of an indexer is to some extent similar to a property. Like properties, you use get and set accessors for defining an indexer. However, properties return a set of specific data member, whereas indexers return a set of particular value from the object instance. In other words, it breaks the instance data into smaller parts and indexes each part, gets or sets each part. An indexer allows an object to be indexed like an array. Define an indexer for a class. This class behaves like a virtual array. You can then access the instance of this class using the array access operator. Use of indexes. The following example demonstrates the concept. Declaration of behavior of an indexer is to some extent similar to a property. Like properties, you use get and set accessors for defining an indexer. However, properties return or set a specific data member, whereas indexers return or set a particular value from the object instance. In other words, it breaks the instance data into smaller parts and indexes each part, gets or sets each part. Defining a property involves providing a property name. Indexers are not defined with names, but with a keyword, which refers to the object instance. When the code is compiled and executed, it produces the following result. Overloaded indexers. The following example demonstrates the concept. Indexers can be overloaded. Indexers can also be declared with multiple parameters, and each parameter may be of different type. It is not necessary that indexers have to be integers. C# allows indexers to be of other types, for example, a string. When the code is compiled and executed, it produces the following result. Attributes. An attribute is a declarative tag that is used to convey information to runtime about the behavior of various elements like classes, methods, structures, enumerators, assemblies, etc. in your program. You can add declarative information to your program by using an attribute. A declarative tag is depicted by a square brackets placed above the element it is used for. Attributes are used for adding metadata, such as compiler instruction, and other information such as comments, description, methods, and classes to a program. The .NET Framework provides two types of attributes: predefined attributes and custom-built attributes. In C#, under different classifications, the attributes are specified, and some predefined attributes are also available in C#. Attribute usage: conditional, obsolete. To create a custom attribute, a few steps have to follow, like declaring a custom attribute, constructing the custom attribute, apply the custom attribute on a target program element, accessing attributes through reflection. Attributes. Syntax for specifying an attribute is as follows. Name of the attribute and its values are specified within the square brackets before the element to which the attribute is applied. Positional parameters specify the essential information, and the name parameters specify the operational information. Syntax for specifying this attribute is as follows. The predefined attribute usage describes how a custom attribute class can be used. It specifies the type of items to which the attribute can be applied. This predefined attribute marks a conditional method whose execution depends on a specified pre-processing identifier. It causes conditional compilation of method calls depending on the specified values such as debug or trace. For example, it displays the values of the variables while debugging a code. Syntax for specifying this attribute is as follows. This predefined attribute marks a program entity that should not be used. It enables you to inform the compiler to discard a particular target element. For example, when a new method is being used in a class, but you still want to retain the old method in the class, you may mark it as obsolete by displaying a message saying the new method should be used instead of the old method. Attributes. The .NET framework allows creation of custom attributes that can be used to store declarative information and can be retrieved at runtime. This information can be related to any target element depending upon the design criteria and application need. Creating and using custom attributes involve 4 steps. Declaring a custom attribute, constructing the custom attribute, applying the custom attribute on a target program element, accessing attributes through reflection. The last step involves writing a simple program to read through the metadata to find various notations. Metadata is data about data or information used for describing other data. This program should use reflections for accessing attributes at runtime. C# versioning ensures that compatibility is maintained between base class versions and derived class versions. They also address subsequent changes in features. C# versioning is a concept relied on inheritance. To implement C# versioning, the following 3 keywords are used: virtual, new, and override. Conclusion. In this chapter, the user would have learned about the C# basics and the following in detail: data types, identifiers, variables and constants, C# statements, object-oriented concept, object and classes, arrays and strings, system collections, delegates and events, indexes, attributes, versioning.